Okay, today we are going to talk about value at risk and expected shortfall. Those two are very well-established measurement of risk. It's widely used in banks and other areas in finance. I look at the let me try the pen. I look at the learning objective requirements from 3 areas. So let me this adjustment. So you need to understand those two measurements are the core, the essentials in risk management process measurement. Okay? So whenever you want to analyze something, you have to measure it, right? They use value at risk and expected shortfall. In CFA curriculum, they ask you to explain the use of value at risk in measuring portfolio risk. This is 2019. Okay. Before that, I remember like sometimes in CFA level 3, I think maybe several years ago, they do also require to be able to calculate it. It seems they lower the standards. You just need to explain the use. However, they do test you different methods of calculating VaR, at least how you compare them, based on my experience with the CFA curriculum. So again, we are using John Hall's 2018 Risk Management and Financial Institutions book. This is also the core curriculum requirement at financial risk management exam. So the question being asked in value at risk calculation is, what loss level is such that we are some % confident that you will not be exceeded in several business days, right? So we are talking about value at risk in daily institutional business operations. So mainly banks. So like how much will they lose in so many days? A lot of times it's 1 day, and then sometimes 90 days, okay, and then it can be annual. Regulators have traditionally used VaR to calculate the capital they require banks to keep. Okay. Again, the FRM certification or financial risk management certification is all about banks. Okay. The market risk capital has been based on 10-day VaR estimated, where the confidence level is 90%. So those are based on Basel Accord. Okay. They have different Basel Act. Those are just well-established rules from regulators. Again, regulators, they know that they need to regulate banks, and they just want to find out a way to regulate it. And then they meet together. Okay. Then they create some method that everyone use to do it. Okay. Credit risk and operational risk capital are based on one year 99.9% VaR. We can see that the market risk, right, is 10-day VaR. Operational risk is 1 year 99.9% VaR. Those are required at FRM exams for my class. It will also you just need to have some understanding of it. Advantage of VaR, it captures important aspect of risk in a single number. Okay, VaR is just a lot of times in dollars. Okay, how much money you can lose. Okay, it's fairly easy to understand. Okay, that was a really simple question: how bad can things get? Right, so that's what regulators want. Example: the gain from a portfolio over 6 months is normally distributed with mean of 2 million and a standard deviation of 10 million. 1% point of the distribution of gain is, so this is a normal distribution, okay, standard normal distribution, right? So we have something called a t-value, okay, or if it's standard normal, it's called a z-value. If it's student t distribution, we call it t-value. So 99%, like 1% point, right? This part is loss. This part is gain, right? So this would be like 2.33. How to get the number? They have a table, okay? You have a table. It's called a t table. You can go use that table, or if you use Excel, it is There are some Excel functions. Okay. So basically, if you are with an average mean of 2 million and a standard deviation of 0, right? It's just mu minus the z value times the standard deviation. So exactly what we are doing here. Okay. And so the most you can lose is $21.3 million. Okay. Over a 6-month period. So interpretation is really important. A lot of times at CFA exams, they will just ask you how to interpret it, right? So the way to interpret VaR would be within a 6-month time horizon, and then with a 99% confidence level, the most you can lose is $21.3 million. Okay. All outcome between a loss of 50 million and a gain of 50 million are equally likely for a 1-year project. The VaR for 1 year, 91. So this is an example. Okay, it's another example from the book. What it says is, see, a outcome between a loss of negative 50 and then a gain of 50 are equally. What equally means uniformly distributed. Okay. So this is negative 50 and then this is 50. Okay. So when you draw, let me draw that again. Okay. Negative 50, right? And then this is 50. Then the probability of distribution is just like this, right? Okay, so it's uniformly distributed. Like 50 minus 50, that's 100, right? So which means each one of that will be 1%. Okay. Each one of the points, right, is negative 49, negative 48. So this is like 49, 48, right? So 99% confidence interval, you just accumulate, right? Just accumulate this and then move it forward until you reach here, right? This covers 99% of the area, and then you have only 1% left here. Okay, so that's why the 99% confidence level of VaR will be $49 million. Here's another example. A 1-year project has 98% probability of a gain of 2 million, 1.5, and then the VaR of 4 million, 99% confidence level is 4 million. So how do we analyze it, right? We would just lay down the probability, 98% of plus 2, right? 1.5% negative 4, then 0.5% negative 10. So we're looking at 99%, right? So you need to just calculate it accumulatively, right? We have only 98% here, so you need to move to the next level. Okay, so that's why the VaR will be negative 4, right? And then if you add those two together, it will be 99.5%, right? And then if we're looking at 99%, we need to also move forward, like there's a negative 10. What if it's 99.5%? A lot of times this is the gray area. Like some people would just say this negative 10. Some people would say it's just negative 4. Following FRM curriculum, it should be negative 10. You just need to move forward. It's like it's a distribution, right? You will not count this point. Okay? You just need to move down a little bit to do the calculation. Okay. So this is you can also draw it, right? Just like what I showed you. I prefer to use tables. You can also draw it out. This is cumulative. It's called CDF, cumulative density function. So that's what it looks like. Okay, so you have 98%, and then you have, because negative 2 of loss means plus 2 of gain. That's what negative 2 means. Then you have $4 million here. That's your loss, right? 98%. Then you have 1.5%, so that's 99.95%. So when I talk about 99.9, right, it's like somewhere here. So like 99.9, 49%. So we can see clearly it's negative 10, right? However, 99.5%, some people will not count these points. They are going to move this a little bit here, and then they will count something here. Okay, so that's again $10 million loss. But some other textbook we just take negative 4 million. So it's just okay. They are not going to test anything. I'm not going to test anything like this in my exam either. So VaR is a loss level that will not be exceeded with a specific probability. Expected shortfall is expected loss given that loss is greater than the VaR. Regulators have indicated that they plan to move from using VaR to using expected shortfall for determining market risk capital. Two portfolios with the same VaR can have very different expected shortfall. Right? The first time when you see it, you have no idea what's going on, but it's actually fairly simple. So that's what it looks like. VaR cares only the point. Okay, ignores anything worse than that. But if you look at those two distributions, they have the same VaR. However, the loss is very different, right? Like if you are in this distribution, you can lose a lot here. Okay, while here you probably lose a lot less, or your loss is not that significant as compared with this distribution. So, but we all know distribution is real, right? We have probability of losing, right? Here, even though it's small, but when it happens, it can be very bad. So, is that making sense? So you can think about some examples, right? Like people worry about airplane travel a lot because even though if you give them 99% confidence interval, it will be very small, right? Like probably zero VaR. However, if it loses, right? If there's a crash, if there is a crash, it can be very big. So let me turn off the phone. And also they have some definition called a coherent risk measurement. Define coherent risk measure as the amount of cash that has to be added to portfolio to make it risk acceptable. They just have some characteristics of a risk measurement. Okay, so I'm not gonna spend some time going over it because it is not necessarily testable. It's more theoretical, I would say. But at FRM curriculum, sometimes exams, they will also ask you to compare expected shortfall and VaR. So that's what we're going to focus on. Okay, so you need to remember this. Okay, VaR satisfies the first three conditions but not the fourth. Expected shortfall satisfies all four conditions. Okay, so you need to know this is a better measurement. Theoretically, but sometimes hard to compute. So I think that's the main takeaway from this. Okay. So each of the two had 99% loss of 1 million and 0% of a loss of 10 million. What's the 90.5% VaR for each project? What is the 97 for each? So we have two projects here, right? So what you need to do is you just need to just lay out, right? A lot of times, just lay out the table like this. When you look at the question, especially if you're an undergraduate student, it can be very confusing. However, if you just lay out the table like this, you will be able to do it, right? So neither loan default, right? How do we calculate it? Because the default rate will be 2%, right? So if neither of them default, that will be this, and that equal to this, right? And then if one of them default, right, 2 times 0.98, that will be 1. And then loan 1, 2 default, it will be the same, right? So that's why we have two of them. Both default would be 0.02 times 0.02. It's not technically 0, but if you look at two or 1 basis point, it is 0.00. Okay. So what is the 99% VaR and expect shortfall for each loan? So we know that if you look at only one project, 98%, right, will be not default, and then 2% you will lose everything, right? For one project, then the VaR for 99% will be -10, and then expect shortfall, because if it default, it's the same, right? So it's like this. What is the 99% VaR and expected shortfall for the portfolio? If you look at 99%, you need to add those, right? So this add that would be 98.75. Then if you add one more, right, 1.25, that would be 90. It's almost 100%. Okay, so 99% VaR will be you only lose one. Okay, and then the expected shortfall. That will be what will happen after that. We can lose $20 million, right? The most will be you can lose $20 million, and then the probability, even though it's low, we still need to calculate it, right? Plus, and then you have $10 million, right? That would be $10 million. Anything above 99%, right? If you add those, I think it's how many of them are above that? It's almost 1%. Okay. Basically, you just need to add those. However, just because there are only 2 decimal points, that makes it 100%. It makes me hard to calculate here. However, there are some small probability, right? It's probably like around 1% here. Time, yeah, 10 million, and then this will be divided by around 1%. So that's your expected shortfall calculation. I will probably go back and review that in class if you get confused on that part. Spectral risk measurement. This is also a theoretical concept. Okay, you need to be familiar with normal distribution assumption. So this is normal distribution assumption. VaR is very easy to calculate. For expected shortfall, they will not require you. You don't need to. You don't have to. Have to remember. For the sole purpose of a requirement for undergraduate finance degree, you don't have to remember those. However, if you're interested in doing more things, I still don't recommend you remember. If you can derive it, that's very different, right? If you can derive it, that would be very different. Changing the time horizon. Yes, the Basel committee also tells you that you can use those to just adjust your like 1 day VaR to maybe 10 day. So let's say your one day VaR is $10 million, and then what is the 10 day VaR? It will be just 10 million times the square root of 10. Then if you want to adjust that to annual, right? Every year annual. You need to remember we have 252 trading days. And then you just need to adjust it that way. Okay, it's not like 360. You just need to remember that. When we when we use VaR to do calculations, certainly to calculate, you need to choose confidence interval and the time horizon, right? And historically, the trading book has been so banks have 2 books. One is the trading book, the other is the banking book. Okay. After 2007, and especially with some credit products, they are thinking about implementing more regulations on the trading book. Confidence level depends on objective. Regulators have used 99% market risk and 99.9% for credit and operational risk. That's historically they use it. They're doing good job so far, other than 2007. That's liquidity. It didn't really let me check the recording to see. It should be okay. Yeah, I was talking about historically they've been using it, and then they think they did a great job. However, some people blame of them of using like those that create some liquidity issue during the financial crisis, and then they are trying to address liquidity concerns, and then they introduce several other regulatory requirements or guidelines. I would say it's not like required right now. So a bank wanting to maintain a AA rating might use confidence level as high as 99.97% for internal calculations. They have different so banks, like big banks, right? The Basel Committee offers them many options. Okay, so if you are a small bank, right, you don't have the ability or in-house risk management team, you will just follow their standard format. They tell you which number to use, which parameter to use, how to do it. If you're a really big bank, right, they give you a lot of flexibility. However, you have to show them that you have a lot of capability, okay, of managing risk internally. We can always aggregate VaR together. Just need to remember you need to consider correlation here. Okay, so it's like in asset allocation efficient frontier, we also have that. Also, like after you have a VaR, right? The first derivative, like if you have two assets, asset one, asset two, you want to know the contribution of each asset to the total value at risk. You just take the first derivative, right? Accordingly, incremental VaR, like if you have asset one and then you add another one to it, right? There is a change of the total value at risk. The increase would be called incremental VaR. Component VaR would be just the amount of money you put into one asset and times marginal VaR. It's called component VaR. If you add all the component VaR together, that would be equal to the total VaR. This is required, okay, to do calculation. I'm able to. You need to be really familiar with it. For this class, I will also give some basic examples and practice problems of calculating those. You need to go back and review how to do derivatives, but the requirement will be less as strict as compared with FRA. So component VaR is very useful. It kind of tell you how much each asset contributes to the total risk of a portfolio, or like if it's operation. Total VaR is just sum of component VaR, provides a sensible way of allocating VaR to different activities. It's called risk budgeting. Okay. This is also one area that in banks that they spend a lot of time on. It's called risk budgeting. And then we talk about let's talk about back testing briefly. Okay. So let's say you give me, right, a bank A told me that your, let's say the market risk 10-day, right? So your VaR will be $10 million. So that's if that's what you give me. I'm a regulator, okay? You are a bank, you have to tell me your calculations, right? And then because the only reason why you need to tell me VaR is because of 10 million, because I will ask you, right? I will ask you to hold 8.25%. I can double check on that. It's called Cook ratio. Okay. I will require you to hold, okay, some part of the money, okay. Probably need to hold like several $100,000 in cash just to hedge that risk. Is that making sense? So that's why banks always want to, they should report the lowest number possible, okay, or at least it should be accurate. However, given that the banks have the incentive to not hold too much cash, so other regulator, I will ask you to back test it, right? If you tell me your 10-day VaR is 10 million, I just want to see in the previous some time period, right? How many times you lose more than $10 million? Because if you lose a lot of $10 million, that may tell me that maybe you don't have a good measurement at all, right? So that's why the back testing is essentially a Bernoulli, okay? Bernoulli distribution. Right? What is Bernoulli distribution? You either violate it, you either violate it or you not violate it. Sorry. So that's why this is a probability of Bernoulli distribution. If you, let's say, if I tested 10 times and then you violate 2 times, does that really mean you are not doing a good job? So we're going to use a probability of Bernoulli distribution here to do the calculations and see whether, so let's just read it. Suppose that theoretical probability of an exception is P, the probability of M or more exceptions in N day is. So we have another confidence interval here. We want to see, so let's say you have a 99% VaR of $10 million and then you violated 2 times, okay, in the previous, let's say, calendar year, right? Now, what is the probability of that happening, okay, if your VaR is right, if your original VaR giving me is right, okay? I will probably spend more time in class, show you guys how to do back testing a little bit, but it will probably not be quite in depth either. Okay, that's all I have for today. Okay, thank you all.